Okay, let's look at lesson 8.7 for today. We are going to first look at the change of base property, which we've already discussed when we started talking about these exponential equations. And I showed you the long way first of solving an exponential equation, said, because really the whole point of solving an exponential equation is we're going to take the log of both sides. And we talked about how you would want to take the log. So like, for example here, maybe just write this off to the side. You'd want to take log base 2 of 2 to the x power equals log base 2, 12. And we talked about how if you have the same base as what this is technically called your argument. We'll get to that in a second. This is the argument. I call it like kind of the answer piece. They will cancel out. And so we'd be left with x equals log 2 base 12. But we talked about in your calculator, you can't really type that in. You can, but I want to show you the way that we've been doing it. So that's kind of your option 1. Option 2, remember, was where I can just take the log of base 10 of both sides because your calculator does have log base 10. That's the log button. And when that happens, again, this doesn't cancel out. Log base 10 and 2 to the x power don't cancel. So we can apply our property here and move that variable to the front. Log 2, x log 2 equals log 12. And we talked about how this is multiplication, right? And so if I want to undo that log 2 being multiplied by x and solve for x pretty much, here's what I get. So I get x equals log of 12 over log of 2. And we type that into our calculator. And our decimal there would be 3.585, blah, 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 blah. So that was our second option. The second option is the preferred way to solve it, but I did, kind of expand on that. And again, I posted a video on why the change of base property exists, but here's another option to maybe think about it. If I just wanted to rewrite this exponential equation in its logarithmic form, we know how to do that. Remember, this is the base. This is log of base 2. You put the answer, or this is the argument next to it that's equal to my exponent. And what is that? This is the same thing that I just solved for right here. And it is the same thing that I solved for here. And so we know that. I wrote the property down there earlier, but here's the property again. That the log of your base goes to the denominator. And the log of your argument, or I sometimes call it that answer part, but I know that's not the correct technical terminology for it, that goes on top. So normal size number stays on top. The lower number kind of move down below, goes in the denominator. So it is easy to see. It is an important property to know, especially as you move into later math and need to kind of change that around. But using your calculator, you can type in alpha Windows 5, and then that will let you type in a log without base 10. But you really want to know how to use this, because what if you don't have access to a calculator that has, like, if you use a regular scientific calculator, you could only type in log of base 10. And log of base 10 is useful in so many different ways. Log of base 10 is what we use most of the time. So we do want to know how to solve it this way as well. Okay, so let's just do a couple of examples of review here. One is we're just going to use the change of base property, make sure we know what it is. And so remember, we can write this as log of 85 of that argument, or the answer, put that over log of 4, and that's going to give me the same thing. And so again, we can just type that into our calculator, log 85 over log 4, which gives me 3.205 when rounding. This next one is just an example, just to review, make sure we know how to still solve equations. This is a log equation, so we'd only have log on one side. We could, if I had log on both sides and it was the same base, then I could maybe cancel that out. But also, notice that my variable is the base. So this is an interesting problem here. So this is kind of like one of the ones that we did at the beginning. I have a log on both sides, or log on only one side, so we're kind of stuck. We can't use any of my properties of cancel anything out. I need to convert to exponential. So if you're stuck in a log equation, convert it to exponential. If you're stuck in an exponential equation, convert it to a log equation. And so we can do that by saying this is my base raised to my power of 1/2 equals my answer, or the argument, of 8. Now, I want to get x by itself, and what's stopping me? Well, I have this exponent here. And we want to think, how could I get that to cancel out? And so we could actually square both sides, because what is x to the 1/2 power? That's really just the square root of x, right? So I can square both sides. I have x equals 64, and there will be my answer. So just a quick review to make sure we know what we're doing there. There's lots of different problems, and that's where these examples can get a little challenging, is because there's lots of different places that your variable can be. So we will do more examples and more review later on. So let's talk now about the final way that we can see a logarithm, and this is the natural logarithm, ln. So if you see ln, that is a logarithm, and it is involving the number e that we talked about. So the number e is known as the natural number, okay? So natural number. And so its value is approximately that 2.7182, blah, 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 blah. I would just memorize up this 2.7182. Just like with pi, you don't really need to know more beyond 3.14159. Not super necessary. So e's sidekick is the natural logarithm, and the sidekick is more of like the inverse. You will get to use the natural log in e in pre-calculus a lot, and especially in regular calculus a lot. So you will see this number and this natural log appear over and over again. So the natural log is a logarithm with a base of e, and it is abbreviated as ln. So these two things are the same. ln is the same thing as log of base e. Again, we're just using different letters to describe the same thing. And again, this is where I know it gets kind of weird, because you're like, we're putting words into math, but you just have to accept it. So log of base e, just like how if I just see something that's like log, that's understood as log of base 10. There's a lot of just words, phrases, things that we need to know in math. So if you just type in your calculator right now, ln 24, you should get 3.17. If we wanted to use a change of base property to prove that to ourselves, that it means the same thing, we could use that change of base property. This is really log of 24 over log of e, and you could type that in your calculator. Log 24 divided by log of e. You have e as it's a number, right? E is just a number. So basically, the natural log is just log of base 2.174 or 2.718, blah, 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 blah. Again, if you type that in, you get 3.718. So that's really what we're doing here. So that's what you see when you see ln. All right, and it follows this same properties as logs because it is just a log. We're just using a different abbreviation for it. So just like before, if I have the log of a base raised or with that argument or that answer piece with the same base, they are going to cancel out. And I proved that to you earlier. I'd be happy to prove that to you again. And this is where we get that idea of, if I have the base with the same exponent raised to a power and I set that equal to something with the same base, your x's have to be equal to each other, basically. So here, what's going to happen is this is basically log base e with the argument of e to the x, right? What do we know about that? They have the same base as the argument. They're going to cancel. So what do we get? X, okay? So basically, the natural log and e there, those are inverses of each other. They're going to cancel out. And so we can apply that property as well with that other property we talked about too, where you can go in reverse. If you have a base raised to a logarithm with the same base, they will cancel out. You're just left with x. So if I have e, the number, raised to, technically the natural log is just log of e, the same base there, it's going to cancel. So same properties, right? So if I wanted to simplify these expressions, it's actually going to be a lot easier than we think, okay? It looks very complex, but we can break this down, right? I'm going to do this just one more time. Remember, natural log is really just log base e. And so this is what we have. They are going to cancel. We've talked about that before. So basically, anytime you see the natural log and e next to each other like this, they are inverses of each other. We just have an answer of 5x, okay? But let's look at number 4. What makes this one kind of different? This one, we have a 3 in front, okay? And this is following that property where if I have e raised to a natural log, those are going to cancel only if I just have a natural log, but I have a 3 in front. what can we do? Well, we can apply the property that we already know. I can move that 3 back up into the power here. So now I can cancel out the e raised to the natural log. What am I left with? X cubed. Okay, same thing here. E raised to the natural log of 2x minus 1. They're inverses of each other. We just have 2x minus 1. This one's kind of interesting. You may think right off the bat, anything raised to the 0 power is 1. But remember, this is a power within a log. It is not a regular power because it's within a logarithm. What do we know about this? What really is going on here? Because again, this is shorthand notation. What is really going on? That 0 is moved to the front. What is really happening here? The 0 is being multiplied by the natural log of e, which cancels out, but that doesn't matter. 0 times anything is still 0. Okay? So make sure you're still keeping that in mind as you solve these problems. Okay, so then this next one. If I take the natural log, again, this is just log of e, so that is, they're going to cancel out. We're left with 4x. And then the final one here, just pay extra attention. If you have a number in front of your natural log, you need to make sure to move that back up into its power before you kind of cancel the e in the natural log. So this is really e raised to the natural log of x minus 1 squared. So here would be my answer, x minus 1 squared. Okay, so same properties as before. Just get in mind e natural log opposites of each other. Okay, so we could also expand and condense them the same way that we would our regular logs. So here, good review. If I have to expand this, I just want to simplify this whole thing first, right? I can use my power rule, power to power. So that 3 is being applied to both. When I do the power rule, I multiply. So this is really the natural log of x to the 9th power over y cubed. And then I can expand. So I'm going to say that this is natural log of x to the 9th minus natural log of y cubed, because the y cubed is in the denominator, therefore it is being subtracted. The x to the 9th is the numerator, therefore it is positive. And then we can now move my exponents to the very front. So we have 9 ln x minus 3 ln y. There would be your answer. We can condense the same way. So in opposite steps, right? We took the powers, moved them back, and moved them to the front. So that's the first thing that I want to do is I want to move them back. Then I can look at my signs to dictate what's going in the numerator, what's going in the denominator. So I'm going to move those back up. So this is really the natural log of a to the 8th plus the natural log of b to the 5th. Both of these things are being added together, therefore they're really being multiplied. So I can now condense, this is really a to the 8th times b to the 5th, all in one group. Parentheses are not necessary, but I do like to write them to show that that is now kind of one group. Okay, so then how do we solve equations with natural logs? The same way that we solve them with regular like a regular exponential equation. So in a regular exponential equation, your goal is to always check, can I have the same base? Well, if you see an e on one side and you don't see an e on the other side, you're never going to be able to get that to happen, right? I can't in any way ever change 8 and change it down to like an irrational number like e. Now, if you have e on both sides, then that's a different story. I don't think we'll see any problems like that, though, because those are pretty easy. So we'll see stuff more like this, where I have this base. I will not be able to simplify 8 to be the same base, right? So we have to then convert it to its logarithmic form, right? If we're stuck in the exponential, I don't have the same base on both sides, I need to convert it to a log. And so instead of taking just the log of both sides, that's not going to get me anywhere, right? That's not going to cancel anything out. What can we do? We can take the natural log of both sides. And what this is going to do is I now have the natural log and my e canceling out. And I can just say 4x equals natural log of 8. And then I'm asking myself, what is the only thing stopping me from having x by itself? Well, the 4 there, so I can divide by 4. And we can type that into our calculator. Natural log of 8 divided by 4. So the natural log button is the same as I think it's the same as your log button. I don't have my calculator with me. You're just going to have to hit the second button or it should be close around, but you should see ln, but otherwise it works the same as your log. Just when it opens up that set of parentheses, make sure to close that parentheses before you hit the divide button, things like that. So it follows the same rules, but you should get about 0.52 there. Okay, so these are actually easier, in my opinion, than the other ones, because the natural log is a log that's created to have the same base as e. Whereas if we look at that example earlier, where was it? Where we had an example earlier, like this, right? My base was 2, and I just took the regular log of it. Well, that's 10. So the natural log is really nice because it's going to cancel out with base e every single time. And so that's going to be really helpful for us. So same thing for number 12. We have the natural log. I'm going to take both sides of the natural log here. And so now the natural log and my e are going to cancel. I'm left with x plus 2 equals natural log of 12. The only thing stopping me here is subtracting 2. So I really get x equals natural log of 12 minus 2. And I'm writing it like this so that way you type it in exactly as you see it. Take the natural log of 12. Remember, close that parentheses, then hit minus 2. And you should get 0.485. Okay? And then the final one here. Here's something that I like about this problem too. Notice that we have a negative 4 in front. And this is if I try to take the natural log of negative 4, don't write this down, e to the negative x plus 2, blah, 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 blah. We have a lot of things going wrong here. First, this negative 4 will not cancel out because it's negative 4 times e. So that is, I mean, you can do the math there. 2.178 times 4, that's going to be 8 point some decimals, right? That's not going to cancel out with base e. So that's already problem number 1. We also can't take the log of a negative number. So we can't do that. So what can we do? Well, let's divide both sides by negative 4. Get rid of that number, right? This negative 4 is being multiplied by this entire thing. Divide by negative 4. So I now have e to the negative x plus 2 equals 8. Now when I take the natural log of both sides, I'm just going to squeeze it in there, then it will cancel. So keep that in mind as well. E is a number. So if I multiply that by anything, then it's no longer going to cancel out with my natural log, which has a base of e, because they're not the same base anymore, right? So don't keep thinking that e is a variable. It's a variable, but it's in place of a number that we actually know the value to versus like x, right? So where x, we don't know what that is. So I have negative x plus 2 equals natural log of 8. Then I can subtract 2 from both sides. So I have negative x equals natural log of 8 in parentheses there minus 2. But then we have negative x. So once you type that in, I would type all this stuff in first. Natural log of 8 minus 2, hit enter. Then I would hit divide by negative 1 to officially clear that out. And you just have x by itself. And so you should get negative 0.079. Okay, so hopefully that was a good review on those exponential equations anyways. But I like the natural log ones better because your base is going to cancel out every time. You won't have to type in 2 logs like we did before. You only have to type in 1 natural log. Okay, let's do a very quick recap here. So log versus natural log. When a log is written without a base, the base is assumed to be 10. When a natural log is written, the base is assumed to be e, which is again a number, 2.7182, with lots of repeating decimals there. So again, this is base 10. Natural log is really log of e, right? But we abbreviate that as ln. Okay, so expressions. If I have a expression like this and I wanted to maybe expand it out, right, that both the log and the natural log would expand out the same way. So this would expand to 2 log base 3 x plus 4 log base 3 y. And I'm hoping we can eventually get to that point right away without having to maybe do that middle step and just kind of visually see how those numbers are rearranging. Works the same for the natural log, right? I can say this is the same thing as 2 natural log of x plus 4 natural log y. Same idea. Different bases though. One has a base of e, one has a base of 3. If I wanted to solve these exponential equations, your first step is to always try to get the same base, okay? Always try to get the same base. Just like how when we're factoring those quadratics, your goal is to always check for a GCF first. Always check for the easiest option. And so in this one, we can see 8 is a perfect cube, 4 is a perfect square. When you have stuff like that, that should be a warning. Hey, I can change those to the same base. So this is really 2 cubed, 2x plus 5, right? Equals 2 squared. You could continue to solve. You could now say this is equal to this. If you do not have the same base, then you need to take the log of both sides. If e is involved in your equation, then you're taking the natural log of both sides, right? So for this first example, I have a base of 7. So we talked about how you can take log base 7 of 7x plus 1, but because of our calculators, we're just going to take the log, just regular log, so base 10 of both sides, and continue solving there. If I have a base e, we have a log that will cancel that out right away, the natural log. So I can take the natural log of e, x plus 1 equals natural log of 15, okay? So hopefully you're getting a little bit more comfortable with recognizing the patterns here. But like I said, we will do lots of review this week on that. So hopefully this lesson went okay. I will be posting the answer key for you guys as well. So if you have any questions, we can talk tomorrow. But have a great day.